Are they really the fastest and most powerful storage for electrical energy that you can get? Today, we are going to talk about supercapacitors, what people call supercaps. What is so special about that material?
Yeah.
4,000 farads drinkable.
So-
Nail polish remover.
Nail polish remover, yeah, exactly. Yeah,
Right.
So,
Welcome to HiFinder Tech Talks. Here we look at the technology that makes the hydrogen economy work. My name is Steven, and today I am joined by Dennis, who is an electrical engineer and has been dealing with supercaps for over 10 years. You've built applications with them, and you work for AEP Hybrid Power, a company that specializes in actually putting the right combination of different kinds of energy sources together for solutions. This is correct, right?
thank you. Yes. Yeah.
Welcome, and thank you for making it all the way from the Netherlands to here. And let's start with the basics. So, Dennis, what is a supercap?
So, to explain a bit more about what a supercap is, I would like to go back to a conventional capacitor.
Yes.
A conventional capacitor is working in a way that you have two plates, and the capacity is depending on the surface of the plate on one hand, and also the distance between the plates. So you want to have the biggest surface and the smallest distance between the plates to have a biggest capacity as possible.
Okay, so no one invites an electrical engineer without getting an electrical diagram, and I see you have one here. So can you take us through this? You showed the plates,
Yes.
right?
So these are the plates that we were talking about, and in a circuit you always need a voltage source,
Yes.
which could be, for instance, a battery.
Yes.
You put a positive, negative charge to it, to the plate, and what happens? The negative ions will flow into the positive plate, and on the other side you will have a shortage of ions, so you get a positively charged state.
And so basically ions flow over here. What is a dielectric? What is that?
The dielectric is between the two plates. They put like a dielectric material
Okay.
to make sure that you have a little bit better permittivity of
Okay,
the capacity.
so it's a special kind of material which you obviously need for that. And,
Yeah.
and the bigger the plate, so that's a bit of a formula there to show, okay, area dependent on that. So basically ions piling up here, and when you take away the power, they're still there and they will create a current. Okay.
Exactly.
So now that is the basic capacitor, but what is now a supercapacitor? And I know sometimes you talk about ultra capacitors even.
Exactly.
So what does that mean?
So with a conventional capacitor, we talk about microfarads.
Yes.
And with a supercapacitor, you talk about several thousands of farad. So it's a million times bigger. So what, in principle, the technology is a little bit different, but it is also comparable to the capacitor. In the supercapacitor, they have made the surface as big as possible, as you can see here.
Yes.
They do it with activated carbon. It's a very porous material, and this creates the very large surface of the electrode.
Yes.
Then supercap has also an electrolyte
Yes.
with a separator in between, which makes them also an electric double layer capacitor. That's the technical name of it. So in principle, you have two capacitors in one housing.
Aha.
What happens if you put these are the plates, you put a positive charge and a negative charge on it, then the ions will start to flow, and what happens? You will create here a small capacitor and here also a capacitor. So therefore the explanation of electric double layer capacitor.
Okay, so that means you have basically like a capacitor set up at this side and a capacitor set up at this side, which is essentially that.
Yeah.
And is my understanding correct that by using these carbon coatings or so, you increase the surface area? So it's just a rough kind of surface, which is more surface area, obviously, than a flat surface.
Exactly,
Okay,
exactly,
alright.
yeah.
Okay.
And also here the distance is very small between the positive and negative.
Yeah.
So therefore, you get a very high capacity.
Okay, and now you keep showing us these diagrams, but I know that the capacitors, when you actually bring them, and I thank you for bringing one, they're actually round. So how does that work?
Yeah, that's also shown in this picture. You have these plates with a positive and negative and a separator in between, and they are like rolled up, like a film that is rolled up.
Okay.
To create a lot of layers inside, because each layer is very thin.
Aha.
And that's also needed to get this amount of capacity.
So that means every film layer here is basically this, and then they are rolled up. but is it one long roll or is it
Yeah.
just repeating in
It's-
concentric circles?
It's one long roll.
One long roll. And where are the ends? You know, so is this one end of the roll
Yeah.
and this is the other end of the roll, or is this connected to every roll,
Yeah.
basically every rotation or whatever, every circle or whatever you
Yeah,
want to call
so,
it?
so in principle, if you can see here,
Yeah.
you have the positive separator and a negative. This
Yeah.
is rolled up.
Yeah.
So all the positives are brought to one pole, and all the negative part of the electrode is to the other side.
To the other side, okay. Yeah, you see a plus and minus there. Okay, so they are all connected. Okay, so I know that, so one cell, it says here 3 volts, okay. And I know that you actually specialize also in putting these things in modules. So how does that work in a module?
Exactly. Normally in an application, you want to have a larger voltage
Yeah.
to make it usable.
Yes,
So 1 cell 3 volt is very small.
yeah.
So you need to connect them in series to get to higher voltage levels.
Okay, okay.
Um,
I actually, one thing I wanted to ask, and I'm sorry for skipping back there, is before we get to the actual series, is just a little bit again about the inside of the actual chemistry. So what is this material, and why would ions do that? Can I use any material? Can I just use wood, or what? You know, like what's so special about that material?
Yeah, this is a material which is also, of course, continuously developing.
Yes.
Because you want to have a good conductivity inside, so that the ions can flow easily. Because this is also creating the resistance inside the capacitor.
Okay.
So the better the conductivity inside, the better the lower the resistance of the capacitor. But you need it also to ionize.
Okay.
The
But what material is it? Does it have a name, or
It's comparable. It's acetonitrile.
Yeah.
So it's comparable to nail remover. So
nail polish remover.
nail polish remover. Yeah, exactly. Yeah.
Right.
So, yeah.
Okay, okay. Good. Okay. So then now with the nail polish remover and 1 cell, and we've got it. So coming back to modules, and I see you even brought one here.
Yeah.
So in this case, we have multiple of these, as far as I see. So how does it work when you actually want to put these in modules?
Yeah. So we connect these cells, like I mentioned before. We connect all these cells in series.
Yes.
To get to higher voltage levels. But due to small internal tolerances of each cell, because they are never 100% exact, there's
Yes.
always one is 3,100 farad, the other one is 3,050 farads. So there are small deviations.
Yes.
And what happens if you put them all in series, you charge them, then you get deviations in voltage levels.
Ah, okay, okay.
Because voltage is quite a critical part of a supercapacitor, you never want to have it overcharged. And also for the longer time, so for the lifetime of a supercap, you want to have them as equal as possible. So to make them all age also on an equal level. So what we do is we have balancing and monitoring of each cell. So each individual cell is being checked on the voltage level.
Yes.
And our monitoring system of AEP makes sure that each cell is charged
Okay.
with the same voltage
So,
level.
so why don't we just go ahead and have a look at that a little bit? Let me see
Yeah.
if I can move this around and
help you.
just get this also a little bit more into the camera. Yeah.
Yeah.
So here, so basically, just what we see here. I mean, we can see it on this side. They all have 2 ends like this one,
Yeah.
and one end is
A
popping
plus
up.
and a minus.
Yeah, plus and a minus, and one end is popping up here,
Yeah.
and at the bottom, the 2 ends are connected with the plate. Yeah, which we
Exactly.
can
Yeah.
see down there. Yeah.
So it's a serial connection of each cell. So
Yeah.
there are 48 cells in the module,
Yeah.
and the plus is being connected to the next minus, and then the other plus is connected to the next minus. So
Okay, so
they're
it's
all in a row.
in serial
Yeah.
connection. Okay, so when we look at the top here, I mean, I think what we can see here is, so which 2 are these 2 connected at the bottom? These 2 will be connected at the bottom, right?
Yeah,
Yes.
exactly.
So, and I mean, from the simple view of it, why do you have more going on here than just a simple connection? What is this, and can you take us through that?
Yes, yes. So each 2 cells are connected here to this balancing board.
Yes.
The middle point of these cells are connected to the display, so we know exactly what the voltage is on one cell and what the voltage is on the other cell.
So this here is connected to the bottom plate. And in this way, you know the current between
The voltage between.
so obviously the current voltage on this one here and the current voltage on this one here.
Exactly,
Okay.
exactly.
And there's your measuring elements there and so on. Okay.
Yeah, and we know exactly what the voltage is. This is sent to a central device,
Yes.
and we can decide. Okay, this cell is more charged than the other cells.
Yes.
So please discharge this cell a bit to make it in line with the other cells.
Okay. And then the information of this, then I would assume probably goes to a central unit
Controller,
here.
yes, yeah.
Okay. And who takes the decision? Is decision taken here, or is it here, or does it go to some central system?
Yeah. So to go a little bit deeper,
Yeah.
the way how AEP is balancing the
Yeah.
cells is on 3 levels.
Yeah.
One on cell level. So what you see here is a balancing board on each cell.
Yes.
The voltage and temperature is being measured. Then from these cells, all information of these cells is collected in an MMU, we call it.
Yeah.
It's a central device of a module.
Yes.
So the MMU is controlling all the cells inside this module.
This one module. Yeah.
Yes. And then we bring a signal out from this module with optocouplers to an MCU.
Yeah, there you have your optical connectors here, right?
Yeah.
You can, yeah, okay.
Yeah.
So that goes in there.
So
okay.
then you also have a good isolation. So we also use these modules in higher voltage systems, and you want to have a good electrical isolation in your communication system. So we use their optocouplers.
Okay. Nevertheless, this gets its power from there, or there's a separate power supply for this?
No, each module is creating its own power, so they don't need a separate power
supply. Okay,
Yeah.
so I don't. Okay, and with that, it's enough power to send out the optical
it's a
signals.
light
Yes.
signal. So on the other end, we receive this light signal, and then we know what is happening.
Okay,
inside.
so you're balancing each cell like this. Is it very similar to the battery management system, kind of, or?
It's comparable because a battery system is also made out of smaller cells.
Yeah.
So it's same happens here. Only the way of treating a supercap is different than a battery. So the inside the real electronics is a bit different than a normal battery.
Okay.
So battery management system.
So if you say the way is a bit different, so I mean, okay, you say you measure the temperature and essentially the voltage, and you have the ability to balance that out. So a module like this, how much power or what does it contain, if I can ask that way?
Yeah.
I mean, we saw this one here is 3,000 farad. Yeah.
Yeah.
So this, how much would that be?
To explain that, I would like to show you also
Take that
the
back.
different technologies that are the most used technologies that are on the market.
Yep.
Because a supercap is often used for power applications.
Okay.
If you look at a capacitor, then the ultracapacitor can store energy, but it's less than compared to batteries or fuel cells. Still, it has much more capacity than conventional capacitors. So it's somewhere in between, and usually what we see is that a supercapacitor can be very interesting technology for capturing regenerative energy or for applications where you need very high power during a short time. Because the big advantage of ultracaps is that you can charge them and discharge them with the same power, and they have a very low internal resistance, and therefore they can deliver a lot of power.
So very quickly.
Very
basically.
quick. They can release it instantaneously, much quicker than even than a battery.
Aha. Okay. So what kind of applications need that kind of energy, basically?
Yeah, you can imagine, for instance, for stabilizing a DC grid.
Yes. Okay.
Where you have a high cyclic load.
Yes.
And you have energy sources that cannot follow this dynamic load.
Yes. Yes.
Their supercaps can be very, very good technology to use.
Okay. To understand. Okay. And just going back to this diagram here we have energy density versus power density. Okay. So this means how much energy am I storing per kilo? So per weight. So there you have batteries higher, and I mean fuel cells. Okay, when they convert from hydrogen also higher. But the supercapacitor in terms of energy density is lower, but seems to be much higher. And this is a logarithmic scale here, in terms of power density. So I do not have to carry much weight to have a lot of power But it's for a short time.
Exactly, yeah. So
Okay.
it really depends on the application, what the best technology source is.
Okay.
And-
Now, this is wild, but this is like a rocket.
Yeah.
Anybody ever thought about building a rocket with this? I mean, if you
Yeah.
if you need a lot
of
of power
boost.
for a short time,
Yeah.
I mean, ever thought about that at AP hybrid power?
We are not into into a rocket or space applications yet.
Okay.
But I know that they are also used for aviation and also for space technology because of the big benefits that they have. They can work with a very big temperature window
Yes.
from -40 to +60 degrees. They also have millions of cycles, and they can last for maybe 10 to 20 years in an application.
So okay. Okay, Dennis, we've seen this now. So having understood this, what is a typical application where we would see a supercup module like this one, for example?
Yeah, I would like to show you first a diagram of a typical system where you can combine a supercap with a fuel cell and with a battery.
Okay.
This is an example of
Yes.
a load what you have here on the left side. So there can be a big motor, or it can be the grid,
Okay.
and you have a system with a fuel cell.
So here's the load here, AC/DC converters. Okay.
Yeah, the
Okay.
DC
So this all
converters.
works on DC, obviously. Yes.
Exactly. You have the fuel cell, which doesn't have a stable output voltage. With
Yes.
a DC-DC converter, you
Yes.
can create it into a DC link.
Yes.
But this fuel cell can never follow the load on the output side.
Yes.
So you need to have some energy storage in
Yes.
between. If you talk about big applications, then you can imagine, you want to have for the short big power peaks,
Yes.
use the supercaps, and for the longer power peaks of let's say a couple of hours,
Yeah.
there you can take the batteries. So this is a typical application where you can have also the three different sources installed,
Combined.
combined. We have built an ultracap system
Ah.
for this application. I would like to show you. This is a very big crane of
Yeah.
1 megawatt can take of power, and this only has to hoist the load and then lower it. And this is a movement of about half a minute. If you would do that with batteries, you would get a very big and expensive system.
Yes.
Doing this with supercaps, you can build it in a very small container or cabinet. Here you see an example where we have included supercapacitor systems inside a cabinet with the DC-DC converter, another converter part, so we can do also the complete interface of a system to make a complete working propulsion system.
Okay, well, this is beautiful. I mean, because this is obviously going up and down, up and down, up and down, up and down.
Yeah.
And I think you mentioned sometime that it can do that. A supercapacitor is happy to do millions of cycles. Yeah.
Exactly.
Whereas batteries tend to get a bad mood after a while. Okay, so that means that the supercap can take the up and down of the crane. Yeah. And then the batteries will obviously help with a longer power supply, all the lights, and then the fuel cell is the basic power of energy on the vessel. Okay.
Exactly.
Wow. So this is a great example. And so what of the cost when we look at all of this? You know, so are supercaps expensive? Are millions being built already?
Yeah.
Can you give us a perspective there?
Yeah. If you look at this application where you need it for a couple of seconds,
Yes.
their supercaps can be much cheaper if you mount them in a system than compared to batteries. If you go for larger systems, then you need to have so many capacitors inside. Then maybe another technology like a battery is more cheaper. So you really need to do a good engineering.
Yeah.
Look at the application. What is the power profile, and how can we solve it with supercaps, a combination of supercaps with battery fuel cell, or only supercaps with a fuel cell.
So okay, that means that a supercap can help make the battery so much smaller that it becomes so much cheaper that it's absolutely paying for itself, kind of. So if you engineer it right,
you can save a
then
lot
it will work.
of money on batteries.
Okay, by using supercaps. Okay, wow. So that means this has great potential. Can you give us a bit of an outlook? Where is this going? What are you seeing in terms of also the hydrogen economy with the supercap?
Yeah. So what we see is on one hand, because of the electrification,
Yes.
more loads are becoming electric,
Yes.
creating a lot of peaks. On the other hand, we have the renewable energy sources that are slow in response times
Yes.
to ramp up the power. And their supercaps can be very good technology for the future. So I see a big future for supercaps to use them there. And I even have a small present for you.
Ah,
I took a capacitor here. That's the only supercapacitor that you can drink because there's beer inside.
okay, wow, this is nice. You see, they have this size of a popular don't drink. Thank you very much by AEP Hybrid Power. Okay,
Enjoy it.
4,000 farads drinkable. Okay, now I'm all flattered. Thank you very much, Dennis, for making it all the way here. This has been super interesting. I hope that you have enjoyed this video as well, like we did. If you did, please subscribe, or actually, you can even like this video and go to highfinder.com, where you can find this kind of materials and other things which are related to the hydrogen economy, which will make the hydrogen economy work better and faster. And as we learned, if you engineer it right, then it's even cheaper. Thank you very much for watching. I hope you watch another video. Thank you very much for coming, Dennis. Have a wonderful day.
Thank you.